Hello, guys. Welcome back to part 5 of the series of revision videos. I hope that is becoming beneficial to you. If you want to, help this channel, this growing channel that I'm trying to build, please subscribe, share the videos, put in your comments and all of that. You can see that these videos are raw, unedited. I mean, edited videos because I don't really have time to be doing editing. My whole purpose is to put the videos out there as quickly as possible to help you guys with your revision. But in future videos, we're going to do a lot of very wonderful things. But this series is just for you to get all, these revision questions and hopefully prepare and pass your SAA C03 exams. Right. Having said that, let's crack on with question number 18. An application development team is designing a microservice that will convert large images to smaller, compressed images. When a user uploads an image through the web interface, the microservice should store the image in an Amazon S3 bucket, process and compress the image with an AWS Lambda function, and store the image in its compressed form in a different S3 bucket. A solutions architect needs to design a solution that uses durable, stateless components to process the images automatically. Which combination of actions will meet these requirements? Choose two. Okay, so A, create an Amazon simple queue service. Configure the S3 bucket to send a notification to the SQS queue when an image is uploaded to the S3 bucket. B, configure the Lambda function to use the Amazon SQS queue as the invocation source. When the SQS message is successfully processed, delete the message in the queue. C, configure the Lambda function to monitor the S3 bucket for new uploads. When an uploaded image is detected, write the file name to a test file in memory and use the test file to keep track of the images that were processed. D, launch an Amazon EC2 instance to monitor an Amazon SQS queue. When items are added to the queue, log the file name in a test file on the EC2 instance and invoke the Lambda function. E, configure an Amazon event bridge, that is Amazon CloudWatch event to monitor the S3 bucket. When an image is uploaded, send an alert to an Amazon Ample notification service topic with the application owner's email address for further processing. Okay, so give you some time to think about the two that will meet the requirements. Okay, so if you look at this question, one of the requirements is that we want the solution that uses durable stateless components to process the images automatically. So automatic processing of the image. So image is uploaded and automatically is processed. So which of these two will be able to do that? So obviously Amazon SQS could help, and convergent Lambda function is also something that can achieve that. So E is going to be out because configuring Amazon Event Bridge and all of that it's not really going to help us achieve that requirement. All right, so question 18, we are choosing the two combinations of actions that will help meet these requirements. So what are the requirements? We want, an action that will automatically process the uploaded image. So If you look at A, it says create an Amazon SQS queue, then configure the S3 bucket to send a notification to the SQL queue when an image is uploaded. So it looks like, automatic image processing. And B, configure the Lambda function to use SQS as the invocation source. So when the SQS message is successfully processed, then you delete the message in the queue. Yeah, so my best bet will be A and B. Let's see. But before that, let's look at Amazon Event Bridge, formerly known as Amazon CloudWatch Events. So Amazon Event Bridge, formerly known as the CloudWatch Events, is a serverless event bus service provided by AWS. It makes it easy to connect different applications using events. That is data from one application that triggers automated actions in another. Okay. Yeah. So Event Bridge also gives an idea of automation. So yeah, it's possible that you might also think that it could be a factor. Okay. Or it could be a possible option to exploit. I think that A and B is probably the best combination of action to meet these requirements. So let's see. Yeah, so the community voted for A and B the most, right? And the answer is A and B. So the thing is this: to design a solution that uses durable, stateless components to process images automatically, a solutions architect could consider the following actions. Option A involves creating an SQS queue and configuring the S3 bucket to send a notification to the queue when an image is uploaded. This allows the application to decouple the image upload process from the image processing process and ensures that the image processing process is triggered automatically when a new image is uploaded. And option B involves configuring the Lambda function to use the SQS queue as the invocation source. Okay, when the SQS message is successfully processed, the message is deleted from the queue. So this is ensure that the Lambda function is invoked only once per image and that the image is not processed multiple times. Right? Now option C is incorrect because it involves storing state. You want stateless, but this involves storing state, the file name in memory, which is not a durable or scalable solution. And option D is incorrect because it involves launching an EC2 instance to monitor the SQS queue, which is not a stateless solution. Option E is incorrect because it involves using Amazon Event Bridge, formerly Amazon CloudWatch Events, to send an alert to an Amazon simple notification service topic, which is not related to the image processing process. So if maybe it was related to the image processing process, then it could have been a contender for the answer. Right. Okay. Right. So question 19. A company has a 3-tier web application that is deployed on AWS. The web servers are deployed in a public subnet in a VPC. The application servers and database servers are deployed in private subnets in the same VPC. The company has deployed a third-party virtual firewall appliance from AWS Marketplace in an inspection VPC. The appliance is configured with an IP interface that can accept IP packets. The solutions architect needs to integrate the web application with the appliance to inspect all traffic to the application before the traffic reaches the web server. Which solution will meet these requirements with the least operational overhead? A. Create a network load balancer in the public subnet of the application's VPC to route the traffic to the appliance for packet inspection. B. Create an application load balancer in the public subnet of the application's VPC to route the traffic to the appliance for packet inspection. C. Deploy a transit gateway in the inspection VP configure route tables to route the incoming packets through the transit gateway. And D. Deploy a gateway load balancer in the inspection VPC. Create a gateway load balancer endpoint to receive the incoming packets and forward the packets to the appliance. Okay, so pretty good questions. So have a think about it. Which one do you think will be the best solution to meet the requirements with the least operational overhead? Okay, so first of all, what we've got is a 3-tier web application and their web service deployed in a public subnet in a VPC. Okay, so yeah, if you look at the option, there's nothing like private mention anywhere, so that is good. If there was any mention of private, then probably you will get rid of that. Eliminating the distractors helps you to focus on those that could potentially be the answer. Now, the application service and database service are deployed in private subnets in the same VPC. Oh, okay, so here we go. Application service and database service are in private subnets. Okay. Now, the company has deployed a third-party virtual firewall appliance from AWS Marketplace in an inspection VPC. The appliance is configured with an IP interface that can accept IP packets. Now, a solution architect needs to integrate the web application with the appliance to inspect all traffic. Okay, so which one is likely to be the answer? Quite a one that is a bit tricky. I'm thinking it's probably B or D, because if you look at B, or let's look at D. Okay, the D involves the use of the gateway load balancer, and this gateway load balancer operates at layer 3 of the OSI model and is built on Hyperplane, which is capable of handling several thousands of connections per second. The gateway load balancer endpoints are configured in VPCs originating or receiving traffic from the internet. This architecture allows you to perform inline inspection of traffic from multiple VPCs in a simplified and scalable fashion while still centralizing your virtual appliances. Okay, now again, the key part is the least overhead. And as you know, the option D adds more complexity and cost. That's what some believe. So if option D adds more complexity and cost, then maybe B should be the answer. So let's see. The answer is B. Interesting. Okay. Now, when I asked ChatGPT, it says the answer is D, which makes it even more interesting. And here is why. He says The gateway load balancer. A gateway load balancer is designed specifically for deploying third-party network appliances. It allows you to route traffic to virtual appliances in a VPC, making it an ideal choice for integrating third-party appliances for packet inspection without significant operational overhead. Okay, so gateway load balance. Somebody said in the community that that option will add complexity, but the explanation here says it doesn't add much operational overhead, and it also gives simplicity, operational efficiency, separation of concerns. Yeah, so what do you think? Leave your answer in the comment. Do you think it is B or D or even A or C? I want you to leave your answer in the comment. I mean, it says it's B, but it looks like D also makes sense. And 81% of the community votes went to D. So what do you think? Leave your answer in the comment. Question number 20. A company wants to improve its ability to clone large amounts of production data into a test environment in the same AWS region. The data is stored in Amazon EC2 instances on Amazon Elastic Block Store, Amazon EBS volumes. Modifications to the cloned data must not affect the production environment. The software that accesses this data requires consistently high I/O performance. The solutions architect needs to minimize the time that is required to clone the production data into the test environment. Which solution will meet these requirements? Okay, so A, take EBS snapshots of the production EBS volumes. Restore the snapshots onto EC2 instance. Store volumes in the test environment. B, configure the production EBS volumes to use the EBS multi-attach feature. Take EBS snapshots of the production EBS volumes. Attach the production EBS volumes to the EC2 instances in the test environment. C, take EBS snapshots of the production EBS volumes. Create and initialize new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment before restoring the volumes from the production EBS snapshots. D, take EBS snapshots of the production EBS volumes. Turn on the EBS Fast Snapshots Restore feature on the EBS snapshots. Restore the snapshots into new EBS volumes. Attach the new EBS volumes into EC2 instances in the test environment. Okay, so you've got a lot to think about. Have a think about it and let us know what you think will be the answer. Okay, so I think if we break it down, the first thing we hear is that, company wants to improve its ability to clone large amounts of production data in a test environment. Now, this data is stored in Amazon EC2 instances on Amazon Elastic Block Store. Normally, we hear it's stored in S3 buckets, but this time it's Amazon Elastic Block Store volumes. Now, what is Amazon Elastic Block Store volumes? Amazon Elastic Block Store provides persistent block storage volumes for use with Amazon EC2 instances. Persistent block storage volumes. Persistent block storage volumes for use with Amazon EC2 instances in the AWS cloud. Okay, so that is the key thing. Persistent block storage volumes. And some of the volume types are solid state drive, SSD, hard disk drive, HDD. Then we have got volume snapshots and all of that. Okay, so that is Amazon EBS, Amazon Elastic Block Store volumes. And is that modifications to the clone data must not affect the production environment. Yeah, because you don't want anything to have to affect live applications. A software that accesses this data requires consistently high input and output performance. Then the architect needs to minimize the time that is required to clone the production data into the test environment. So what will the architect do? So obviously we are talking about EBS and EC2 here. Okay. So if you want to, the objective is to minimize the cloning time of the production data into the test environment. Then we have to look at among the options, which of them will be able to deliver on that requirement. Now, and we look at it, it looks like for A, C, and D, one thing is clear. You have to take EBS snapshots of the production EBS volumes. That is how you clone the production data into the test data. Okay? But if you come to D, after doing that, it says turn on the EBS fast snapshots restore feature on the EBS snapshots. Okay, so we want to minimize the time that is required to clone the production data. So turning on the EBS fast snapshots restore feature is very, very critical. It's key to helping us achieve that, I believe. So after that, you restore the snapshots into new EBS volumes and attach the new EBS volumes to EC2 instances in a test environment. So I'll actually go for D because it kind of meets all the requirements, I believe. So let's see. Okay, so answer is D. Answer is D. Okay. Yeah. So that is question number 20. We moving on to 21. Question number 21. An e-commerce company wants to launch a one deal a day website on AWS. Each day will feature exactly one product on sale for a period of 24 hours. The company wants to be able to handle millions of requests each hour with millisecond latency during peak hours. Which solution will meet these requirements with the least operational overhead? So you can see that one of the big things for companies is choosing a solution that will meet or that will require the least operational overhead. Okay, I mean, that is the whole idea about technology anyway, So what are the options? A, use Amazon S3 to host the full website in different S3 buckets. Add Amazon CloudFront distributions. Set the S3 buckets as origins for the distribution. Store the other data in Amazon S3. B, deploy the full website on Amazon EC2 instances that run in auto-scaling groups across multiple availability zones. Add an application load balancer to distribute the website traffic. Add another application load balancer for the back-end API. Store the data in Amazon RDS for my SQL. C, migrate the full application to run in containers. Host the containers on Amazon Elastic Kubernetes service. Use the Kubernetes cluster autoscaler to increase and decrease the number of pods to process bursts in traffic. Store the data in Amazon RDS for my SQL. D, use an Amazon S3 bucket to host the website's static content. Deploy an Amazon CloudFront distribution, set the S3 bucket as the origin, use Amazon API Gateway and AWS Lambda functions for the back-end APIs, store the data in Amazon DynamoDB. Okay, great question. So have a think about it and let us know what you think the answer is. All right, so as always, the solution that will require the least operational overhead. Okay, so the company wants to handle millions of requests each hour with millisecond latency during peak hours from their website. Okay, so if you look at the options, I believe definitely S3 can be used to host the website, especially the static content of the website. Yeah. So I believe that any option that has contained S3 is a good contender for the answer. So B and C should be out. And we can focus on A and D. Okay. Yeah. Now, if you look at A, it says use S3 to host the full website in different S3 buckets. And if you look at D, use an Amazon S3 bucket to host the website static content. If you compare the two, A and D, the one which is scalable, infinitely scalable seems to be D. Okay, because if you use S3 to host the website static content, it is scalable than trying to host the full website. Okay, so I will probably go for D as the answer. Oh, the community voted for D 100%. Okay. So as I said, using Amazon S3 to host static content and Amazon CloudFront to distribute the content can provide high performance and scale for websites with millions of requests each hour. Amazon API Gateway and Amazon Lambda can be used to build scalable and highly available backend APIs to support the website. And Amazon DynamoDB can be used to store the data. This solution requires minimal operational overhead as it leverages fully managed services that automatically scale to meet demand. That's it. Now, option A is incorrect because using multiple S3 buckets to host the full website would not provide the required performance and scale for millions of requests. It's not scalable. It's not infinitely scalable. Option B is incorrect because deploying the full website on EC2 instance and using an application load balancer and an RDS would require more operational overhead to maintain. Yeah, so that is why it's not feasible for option B. Option C is incorrect because while deploying the application in containers and hosting them on Amazon Elastic Kubernetes Service can provide high performance and scale, it will require more operational overhead to maintain and scale the infrastructure compared to using fully managed services like S3 and CloudFront. Yeah, so yes, if the company didn't mind high operational overhead, then probably C would have been a very good competitor for the answer. But because cost is a concern for them, then you want to find one which is infinitely scalable and has got high performance and at the same time offering least operational overhead. And D seems to be the one that meets this requirement. All right, question 22. A solutions architect is using Amazon S3 to design the storage architecture of a new digital media application. The media files must be resilient to the loss of an availability zone. Some files are accessed frequently, while others are rarely accessed in an unpredictable pattern. The solutions architect must minimize the cost of storing and retrieving the media files. Which storage option meets these requirements? Okay, so we've got A, S3 standard, B, S3 intelligent tiering, C, S3 standard infrequent access, that is S3 standard IA, and D, S3 one zone infrequent access. Okay, so I think it's S3 intelligent tiering because, it says that some files are accessed frequently while other files are rarely accessed. So the intelligent tiering will be able to cater for these different file requirements. So I believe the answer should be B. Yeah, and the community definitely voted for B 100%. Right, so let's read a bit about the answers. So we know that the answer is S3 intelligent tiering. Now, Amazon S3 intelligent tiering is a storage class that automatically moves data to the most cost-effective storage tier based on access patterns. It can store objects in two access tiers, the frequent access tier and the infrequent access tier. The frequent access tier is optimized for frequently accessed objects and is charged at the same rate as standard, S3. The infrequent access tier is optimized for objects that are not accessed frequently and are charged at a lower rate than the S3 standard. S3 intelligent tiering is a good choice for storing media files that are accessed frequently and infrequently in an unpredictable pattern because it automatically moves data to the most cost-effective storage tier based on access patterns, minimizing storage and retrieval costs. It is also resilient to the loss of an availability zone because it stores objects in multiple availability zones within a region. Okay? Now, option A is S3 standard. It's not a good choice because it does not offer the cost optimization of S3 intelligent tiering. And S3 standard infrequent access is not a good choice because it's optimized for infrequently accessed objects and does not offer the cost optimization of S3 intelligent tiering. It's both frequent and infrequent that we have here. And option D, S3 one zone infrequent access is not a good choice because it's not resilient to the loss of an availability zone. It stores objects in a single availability zone, making it less durable than other storage classes. A company is storing backup files that is question 23. A company is storing backup files by using Amazon S3 standard storage. The files are accessed frequently for 1 month. However, the files are not accessed after 1 month. The company must keep their files indefinitely. Which storage solution will meet these requirements most cost effectively? So configure S3 intelligent tiering to automatically migrate objects. B, create an S3 lifecycle configuration to transition objects from S3 standard to S3 Glacier Deep Archive after 1 month. C, create an S3 lifecycle configuration to transition objects from S3 standard to S3 standard infrequent access, S3 standard IA after 1 month. And D, create an S3 lifecycle configuration to transition objects from S3 standard to S3 one zone infrequent access, S3 one zone IA after 1 month. So if it's never going to be accessed, the files are not going to be accessed after 1 month, but it needs to be stored indefinitely, then I think you need to push it to Glacier Deep Archive after 1 month. So, yep, B should be the answer. Yeah, and that is correct. Okay, that was easy. Question 24. A company observes an increase in Amazon EC2 costs in its most recent bill. The billing team notices unwanted vertical scaling of instance types for a couple of EC2 instances. A solutions architect needs to create a graph comparing the last 2 months of EC2 costs and perform an in-depth analysis to identify the root cause of the vertical scaling. How should the solutions architect generate the information with the least operational overhead? Okay, so A, use AWS budgets to create a budget report and compare EC2 costs based on instance types. B, use Cost Explorer's granular filtering feature to perform an in-depth analysis of EC2 costs based on instance types. C, use graphs from the AWS billing and cost management dashboard to compare EC2 costs based on instance types for the last 2 months. And D, use AWS cost and usage reports to create a report and send it to an Amazon S3 bucket. Use Amazon QuickSight with Amazon S3 as a source to generate an interactive graph on an instant types. So which of them do you think would be the answer? Interesting. Which of them will be the answer? So they just want to compare instant types for a couple of EC2 instances, comparing the last 2 months of EC2 costs and perform an in-depth analysis. So they are not just comparing, they also want to perform an in-depth analysis. Okay. Okay, so in-depth analysis. Okay, so C says use graphs from the AWS billing and cost management dashboard to compare EC2 costs based on instant types for the last 2 months. So he has mentioned last 2 months. The rest, it looks like they no mention of last 2 months. So even though, for example, B can also be an answer, I would rather go for C. Yeah. Oh, the answer is C, but only 25% people voted for it. Okay. Interesting. If you look at the other options, A can be, as the result is a report. So it's a graph that we want, but this A is going to generate a report. And if you look at B, Cost Explorer, using granular filtering, it's limited to 14 days visibility and the graph has to cover 2 months. So it doesn't help much. You want 2 months comparison of graphs, but that option will only give us 14 days. And if you look at C, it seems to provide graphs and the best option available. And D could provide graphs, but involves operational overhead, which has been requested to be minimized. So that is why, the answer is C. Okay, because not only will it meet the requirements, it will also meet the most important requirement, being least operational overhead for the company. So the answer is C.